Okay, imagine this. You need to monitor water levels, but it's like on this remote volcanic island way out in the Pacific.
Oh, wow.
Installing and maintaining like a traditional tide gauge out there,
Right.
that would be a total nightmare. So what do you even do?
Yeah.
Well, that's where today's deep dive topic comes in.
Okay.
It's GNSS-IR.
Cool.
And it can actually monitor water levels all over the world using just the signals from satellites we use for GPS.
Wow.
You don't even need any equipment in the water.
That's pretty amazing.
Yeah. We've got a whole stack of research papers and resources on this,
Cool.
and I'm so excited to unpack them all.
Yeah, what's really fascinating about GNSS-IR is that it uses those familiar GPS satellites,
Right.
but instead of telling you where you are,
Right.
it analyzes how their signals bounce off surfaces like water.
It's like GPS has a secret superpower.
Oh.
I was looking through these papers, and some of them had me hooked just from the titles.
Oh, really?
It's like a novel tropospheric error formula.
Yeah.
That sounds intense.
It is. It tackles a big challenge.
Okay.
The atmosphere actually messes with those satellite signals,
Oh.
and researchers are constantly refining ways to correct for that.
So it's not just a straightforward measurement.
No, not at all.
Okay, so before we get into like the nitty-gritty,
Sure.
let's make sure our listener understands how GNSS-IR even works in the first place.
Yeah, good point.
Okay, so we've got our GNSS receiver, just like the one in your phone,
Right.
picking up signals from those satellites way up in space.
Way up.
The signals zip through the atmosphere,
Okay.
and then bam,
Bam.
they hit the receiver.
Mm-hmm.
But how does this tell us about water levels?
Okay, well, here's where things get really cool.
I'm ready.
So think of a satellite signal hitting the water's surface.
Okay.
Part of that signal bounces off the water before it hits the receiver.
So the receiver is getting two signals,
Exactly.
the direct one from the satellite
Right.
and a reflected one from the water.
Yes. And here's the key. Those two signals interfere with each other,
Good.
creating a unique pattern.
Okay.
It's kind of like dropping two pebbles in a pond.
Uh-huh.
You know, the ripples will overlap
Yeah.
and create a new pattern.
Right.
Well, it's similar to that. And that pattern, that new pattern,
Yeah.
is captured in what's called the signal-to-noise ratio data
Okay.
from the receiver.
So it's like we're looking at the ripples.
Yeah,
That
exactly.
makes sense. But how do we go from a signal pattern
Right.
to an actual water level measurement?
Okay. So
I mean, is there some kind of code we have to crack?
it is kind of like code breaking.
Oh, wow.
The interference pattern actually tells us the height difference
Okay.
between the receiver and the water.
So that's how we get the measurement.
Yeah.
Okay.
So the clever part is GNSS-IR uses what's usually considered an error in GPS,
Right.
that reflection,
Uh-huh.
and turns it into useful information.
It's like finding treasure in your junk drawer. So I was reading about this and I saw there were different ways to kind of decode the signal.
Right.
As they talk about spectral analysis and inverse modeling.
Yeah.
To be honest, those sound pretty intimidating.
I can break those down for you.
Okay. Thanks.
So spectral analysis is the simpler one.
Okay.
Imagine listening to an orchestra and picking out the different instruments.
Okay.
That's kind of what we're doing here with spectral analysis.
Oh, right.
We're analyzing the frequencies in the signal
Okay.
to figure out the height of the water.
So if we hear a high-pitched flute, that means the water level is high.
Uh-huh.
And if it's a deep tuba, the water level is low.
Not quite that literal, but you've got the right idea.
Okay.
It's about identifying patterns in the signal.
Yeah.
But like any good orchestra, there can be a lot of noise.
Right. All those other instruments.
Yeah, exactly.
Okay.
So that's where inverse modeling comes in.
Okay.
It's like using noise-canceling headphones
Ah.
to get a clearer picture.
So it filters out the distractions.
Yes.
How does it do that?
It gets a bit more technical here,
Okay.
but basically, researchers use some clever math tricks
Yep.
to model how the water level changes over time.
So they're kind of predicting where it's going to be.
Yeah, in a way.
Okay.
And this allows them to track things like tides and waves really accurately,
Oh, wow.
even with all that noise from the environment.
So spectral analysis is like listening to a live concert,
Uh-huh.
while inverse modeling is like listening to a studio recording.
That's a great way to put it.
Okay, I like it.
Yeah. And actually, one of the papers, bachelor thesis Sen Wagner final,
Right.
has some really helpful visuals.
Oh, perfect.
Figure 1.1 shows the whole GNSS-IR setup,
Okay.
and figures 2.14 and 2.15 show how they use spectral analysis to analyze the signal.
I'll have to check those out.
Yeah, they're really helpful.
Okay, so we've kind of got the basic idea now of how GNSS-IR works.
Right.
But let's talk real-world accuracy for a second.
Okay, sure.
I mean, we're dealing with signals traveling from space,
Yeah?
bouncing off moving water.
Uh-huh.
Seems like there could be a lot of room for error.
You've got a good point.
Yeah.
There are a bunch of factors that can mess with the accuracy of those measurements.
Like what?
Well, the atmosphere itself is a big one.
Oh, right.
As GNSS signals pass through the atmosphere, they slow down,
Okay.
which is called tropospheric delay.
So it's like the signal is taking a detour through a cosmic traffic jam.
Exactly, and that throws off our calculations.
Oh, no. So how do we account for that?
Well, remember that detective novel title I mentioned
Oh,
earlier?
yeah, the novel tropospheric error formula.
That's the one.
Okay.
That paper actually introduces a new way to correct for this delay,
Oh, cool.
especially for long-term monitoring of things like sea level rise.
So this formula is like a detective's magnifying glass,
Uh-huh.
helping us see the truth through the atmospheric haze.
Exactly.
That's pretty cool. But is the atmosphere the only thing we have to worry about?
Unfortunately, no.
Okay.
The roughness of the water surface also plays a role.
Okay.
Think about it. A calm lake will reflect a signal differently than a stormy ocean.
That makes sense.
Yeah.
So wind, waves, even a passing boat, they can all add noise to the data?
Exactly. Rougher surfaces scatter the signal,
Okay.
making the height estimate less accurate.
So how do we deal with that?
Well, bachelor thesis Fenn Wagner final talks about these limitations.
Okay.
And on the impact of sea state on GNSS-IR polarimetric observations, dives even deeper into this.
Oh, wow. So how do researchers deal with all this extra noise in the signal?
Right. Well, there are a few tricks of the trade.
Okay.
One is carefully choosing the satellite signals they analyze.
Okay.
Imagine it like virtual filters.
Okay.
They're called azimuth and elevation masks.
So they're filtering out the clutter.
Yes. They help us focus on signals bouncing off the water
Okay.
and ignore the ones bouncing off, say, buildings or mountains. Bachelor thesis Sven Wagner final actually has some good diagrams of this,
Oh, perfect.
showing how they use something called Fresnel zones to pinpoint the reflecting surface.
Okay, so we're filtering out the clutter and focusing on the clearest signals.
Exactly.
Smart. But besides monitoring sea level rise, what else can we use GNSS-IR for?
Oh, lots of things.
Okay.
Could it tell us if a lake is about to overflow, for example?
That's what I was thinking. Like, could we use this for flood prediction?
That's actually one of the most promising applications.
Really?
Real-time water level monitoring using GNSS-IR could revolutionize flood forecasting.
Okay, now that would be huge.
Think of a community
Okay.
along a flood-prone river.
Right.
With GNSS-IR, they could get early warnings,
Oh, wow.
giving them more time to prepare and potentially saving lives and property.
That's incredible.
Yeah, and Geophysical Research Letters 2024 Purnell Real-Time Water Levels using GNSS-IR, a potential tool for flood monitoring, specifically talks about this.
I think I saw that one, yeah.
It highlights how low-cost GNSS antenna arrays can actually provide real-time data that's accurate enough for effective flood monitoring.
So we're talking about making this technology more accessible and affordable.
Exactly.
That's a game changer for so many communities.
Definitely.
So we got sea level monitoring, flood forecasting,
Right.
anything else GNSS-IR can do.
It can even help us monitor sea ice.
Wait, sea ice?
Yeah.
How does that work?
Think of it like this.
Okay.
Open water and ice will absorb and reflect the signal differently.
Oh, okay.
So by analyzing those subtle differences in the reflected signal,
Yeah.
we can actually see the presence of sea ice.
And we're not just measuring the height of the water, we're actually detecting the presence of ice.
Yes, exactly.
Amazing.
And new methods and applications for interferometric Strandberg talks about this.
Okay.
And there's another paper, Real-Time Sea Level Monitoring Using Kalman Filtering of GNSS-IR Data.
Right.
That uses a Kalman filter approach for sea ice detection.
I had no idea GNSS-IR was so versatile.
It really is.
We've got to talk more about these applications
Yeah.
and the advancements in the technology.
Absolutely.
Well, I'm ready to dive deeper.
Okay, let's do it.
Lead the way.
All right.
Okay, I'm officially blown away by all the things GNSS-IR can do.
Yeah, it's pretty amazing.
We've talked about sea level monitoring, flood forecasting,
Right.
even sea ice detection.
Uh-huh.
But what's really exciting to me are the advancements happening in the technology itself.
Yeah, there's a lot going on.
What's on the horizon?
One thing that's making GNSS-IR even more powerful
Okay.
is the use of low-cost GNSS antenna arrays.
Okay, so instead of relying on expensive, specialized equipment,
Right.
Researchers are figuring out how to use more affordable components to get great results.
Exactly. And it's opening up a lot of possibilities.
So it's like going from a fancy sports car
Okay.
to a reliable, fuel-efficient sedan.
I like that analogy.
You still get where you need to go,
Uh-huh.
but it's more practical and accessible.
Yeah, exactly.
Precise water level measurements using low-cost GNSS antenna arrays explores this in detail.
Right.
And Dave Purnell's thesis talks about how these low-cost systems are being developed.
Yeah.
What's really cool is that bachelor thesis Sven Wagner final
Okay.
actually has an appendix that shows you how to build your own low-cost GNSS receiver.
Wow, DIY GNSS-IR.
Yeah.
That's incredible.
I can just imagine citizen scientists all over the world setting up their own water monitoring stations.
That's really cool.
That's amazing. What other advancements are we looking at?
Another exciting area is multi-frequency and multi-constellation GNSS.
Okay.
So instead of just using signals from GPS,
Right.
we can now combine signals from multiple systems,
Like what?
like Galileo, GNSS, and Beidou.
Wow.
And each of those has different frequencies.
Okay, hold on. It sounds like we're conducting a global satellite orchestra here,
Haha, yeah, kind of.
with all these different systems and frequencies working in harmony.
Yeah.
How does that make GNSS-IR better?
Think of it like this. The more signals we have,
Okay.
the clearer the picture we get.
Okay.
It's like having multiple witnesses to an event.
Okay.
They all have slightly different perspectives,
Yeah.
but together they give us a more complete understanding of what happened.
That makes sense. So we're essentially eliminating blind spots
Yes.
and reducing the chances of error.
Exactly.
Does the research support this idea?
Absolutely.
Okay.
Improving consistency of GNSS-IR reflector height estimates between different frequencies
Okay.
shows how combining signals, especially newer ones like L2C and L5Q,
Right.
makes the results much more reliable.
Okay, so we're getting a clearer, more consistent signal.
Right.
But I'm guessing it's not as simple as just plugging in more satellites, right?
You're right. It's not that easy.
Okay.
Each signal has its own quirks
Okay.
and potential error sources that need to be accounted for.
So it's kind of like having a team of superheroes,
Right.
each with their own unique powers and weaknesses.
Yeah, that's a good way to think about it.
We need to understand how to use them effectively to get the best results.
Exactly.
What else are researchers working on to improve GNSS-IR?
Data processing is another big one.
Okay.
Think of it like this. You've got all these signals coming in,
Right.
but you need to sift through them, filter out the noise,
Right.
and extract the meaningful information.
Okay, so that's where those advanced techniques like multi-channel singular spectrum analysis
Right.
or MSSA and Kalman filtering come in.
Exactly.
Okay, so those are the noise-canceling headphones we talked about earlier, helping us tune out the distractions
Right.
and focus on the important signals.
Exactly.
Do any of the papers talk about these techniques in detail?
Yes. Improving consistency of GNSS-IR reflector height estimates between different frequencies
Okay.
and real-time sea level monitoring using Kalman filtering of GNSS-R data both delve into how these techniques are used to improve the accuracy of GNSS-IR measurements.
This is all so fascinating. It's amazing to see how much effort is going into making GNSS-IR even better.
Yeah, it's really exciting.
But all these advancements have real-world applications, right?
Yeah, absolutely.
Yeah.
We've already touched on some of them,
All right.
but there's a lot more to explore.
Okay. Yeah.
Let's start with sea level monitoring.
Okay.
GNSS-IR has the potential to play a huge role in understanding climate change
Right.
and its impact on our coastlines.
Right. Because as global temperatures rise, sea levels are also expected to rise.
Exactly.
And that's a big concern for coastal communities around the world.
It is a big concern.
Yeah.
But monitoring sea level isn't as simple as it sounds.
Okay.
There are all sorts of factors that cause the sea level to fluctuate,
Like what?
from tides and currents to atmospheric pressure
Okay.
and even the melting of glaciers and ice sheets.
So it's like trying to solve a giant puzzle with all these different pieces contributing to the overall picture.
Exactly.
How does GNSS-IR help us put the pieces together?
One of the key things is that it can capture a wide range of frequencies.
Okay. Frequencies
I know.
I'm still having flashbacks to my high school physics class. What do we mean by frequencies in this context?
Think of it like this. Sea level changes happen on different time scales.
Okay.
You have tides, which go up and down every few hours.
Right.
Then you have longer-term changes,
Okay.
like those caused by melting ice sheets,
Right.
which happen over years or even decades.
So it's like the difference between a heartbeat and the changing seasons?
Exactly. And GNSS-IR can capture both those short-term blips and those long-term trends.
Wow, so it's really versatile.
It is.
By analyzing those different frequencies, we can start to tease apart the different factors that are contributing to sea level change.
That's the goal.
This is pretty mind-boggling. It's like we're using signals from space to unlock the secrets of the ocean.
Yeah, it's pretty amazing.
How do researchers actually study those different frequencies? What tools do they use?
They use a lot of different mathematical and statistical techniques.
Okay.
Some of them we've already touched on, like spectral analysis, which helps to identify the dominant frequencies in the signal.
Okay.
But there are also techniques like harmonic analysis
Right.
and wavelet analysis,
Okay.
which allow them to break down the signal into its component frequencies.
Okay, so it's like using a prism to split white light into its different colors.
Yes.
Only in this case, we're splitting the sea level signal into its different frequencies.
Exactly.
And by studying those different colors,
Right.
we can gain a much deeper understanding of the complex dynamics of sea level change.
That's the idea.
This is seriously impressive. I'm in awe of the scientists and engineers who are working on this.
It's amazing work.
But let's get specific. Are there any research studies that really stand out in this area?
Absolutely.
Okay.
One study that comes to mind is the one by Larson et al.,
Okay.
published in 2017.
Okay.
It's titled Tidal Harmonics Retrieval using GNSS-R Dual Frequency Complex Observations.
Okay. I remember that title from our stack of papers.
Yes.
What did they find?
They used 6 years of GNSS data from a coastal station in Sweden
Okay.
and compared the sea level measurements derived from GNSS-IR
Okay.
with those from a traditional tide gauge.
So they were comparing it to the gold standard.
Exactly.
Okay.
And the results were amazing.
What did they find?
They found that GNSS-IR was able to accurately capture a wide range of tidal frequencies,
Okay.
from those short-term ones that happen twice a day
Okay.
to the longer period tides that happen over weeks or months.
So GNSS-R was able to keep up with the tide gauge,
Yes.
providing equally accurate measurements.
It even did a better job of capturing those high-frequency variations that traditional tide gauges sometimes miss.
Wow, so we're getting a more detailed, more nuanced view of the tides with GNSS-IR.
Precisely.
Okay.
And that level of detail is important for understanding how tides interact with other coastal processes,
Like what?
like erosion and sediment transport.
This is fascinating. We're talking about using signals from space to study something as seemingly mundane as the tides. But it turns out to be incredibly complex and important.
It is. It really is.
Yeah.
And it's not just about the tides themselves.
Okay.
GNSS-IR can also help us monitor long-term trends in sea level,
Right.
which is essential for understanding the impacts of climate change.
Right, because as global temperatures rise and glaciers melt, we expect to see a gradual increase in sea level.
Right.
And that could have devastating consequences for coastal communities.
Exactly. But the challenge is separating out the natural variability in sea level
Okay.
from the long-term trend caused by climate change.
Right, so we need to be able to tell the difference between the natural ups and downs
Uh-huh.
and the long-term trend.
Exactly.
But-
It's like trying to untangle a giant knot
Okay.
with all these different factors intertwined.
And GNSS-IR is the tool that helps us unravel that knot.
Exactly. By providing continuous, high-precision measurements over long periods,
Okay.
it gives us the data we need to track the rate of sea level rise
Okay.
and understand how it's changing over time.
This is starting to feel like a detective story, with GNSS-IR as our trusty sidekick,
Uh-huh. I like it.
helping us solve the mysteries of the ocean.
And just like in any good detective story,
Yeah.
the evidence is crucial.
Right.
And GNSS-IR provides that evidence,
Okay.
allowing us to track those subtle but relentless changes in sea level.
This is heavy stuff, but it's also incredibly empowering.
It is.
By understanding these processes,
Uh-huh.
we can start to develop strategies to mitigate the impacts of sea level rise
Right.
and protect vulnerable communities.
Exactly. And that's why research like the Larson study is so important.
Okay.
It demonstrates the potential of GNSS-IR as a powerful tool for monitoring sea level,
Okay.
both in terms of understanding the tides and tracking long-term trends.
I'm definitely adding sea level detective to my resume after this.
Uh-huh. That's good.
But our deep dive into GNSS-IR isn't over yet.
No, it's not.
There's another critical application we need to talk about,
Right.
flood monitoring.
Yes, as we discussed earlier. Real-time water level monitoring using GNSS-IR could revolutionize flood forecasting
Right.
and early warning systems.
Okay.
And with extreme weather events becoming more frequent and intense,
Right.
this is more crucial than ever.
Absolutely. Floods can be incredibly destructive and costly.
Yeah,
So having accurate and timely warnings can make a huge difference in protecting lives and property.
for sure.
How does GNSIR actually help us predict floods?
Well, by providing continuous
Er,
real-time measurements of water levels in rivers and lakes,
Okay.
GNSS-IR can help us see when and where floods are likely to occur.
So it's like having an extra set of eyes on those waterways,
You can-
constantly monitoring the situation
Ah,
and alerting us to any potential threats.
exactly.
That's a reassuring thought.
It is.
And unlike traditional flood monitoring systems,
Right.
which rely on sensors placed directly in the water,
Mhm.
GNSS-IR can take those measurements from a safe distance, right?
Yes. That's a huge advantage,
R-
especially in areas where it's dangerous to access the water
Right. No.
during a storm.
Makes sense. Yeah.
And it makes GNSS-IR particularly valuable for monitoring remote or inaccessible waterways,
Okay.
where it's difficult to install those traditional sensors.
So we're talking about expanding the reach of flood monitoring to areas that were previously underserved
Exactly.
that could potentially save lives and protect property in communities that are particularly vulnerable to flooding.
Absolutely.
So GNSS-IR has a few special superpowers that make it particularly well suited for flood monitoring.
Right. We talked about that.
First, it's incredibly sensitive,
Ah,
able to pick up even tiny changes in water level.
right.
So it's like a canary in a coal mine,
Uh-huh. I like that.
alerting us to even the slightest hint of trouble.
Perfect analogy. And because it uses signals from space,
Yeah.
it's unaffected by things like debris in the water
Okay.
or changes in water clarity,
Okay.
which can sometimes mess with those traditional sensors.
We're getting a clear signal even when containers are murky.
That's right.
That's impressive. Anything else on the superpower list?
Oh, there's more. Spatial coverage is another one.
Okay.
A single GNSS receiver can monitor a wide area.
So we don't need to have a sensor every few feet along the river.
Exactly.
Oh.
Which means you don't need to install tons of sensors along a river or around a lake.
So we're getting more bang for our buck with GNSS-IR.
Right.
It's efficient and cost-effective,
Uh-huh.
especially compared to the expense of maintaining a whole network of traditional sensors.
Yeah, absolutely.
This is starting to sound like the ultimate flood monitoring solution.
It has a lot of potential.
But I'm guessing there are still some challenges to overcome.
You're absolutely right.
Okay.
One of the key challenges is ensuring the data is processed and analyzed in real time.
Okay, so it's not just about collecting the data.
Right.
It's about making sense of it instantly
Nah.
and getting that information to the right people.
Exactly.
Okay.
And that requires some seriously sophisticated algorithms and powerful computers to crunch all those numbers.
Right.
Another challenge is integrating GNSS-IR data with other flood forecasting models and systems.
So we're talking about taking those real-time water level measurements and combining them with things like rainfall forecasts and river flow models to create accurate flood predictions.
Precisely.
Mm.
And that requires seamless data sharing and communication between different agencies and organizations.
So we're talking about a team effort,
Right.
bringing together different expertise and resources to create a comprehensive flood monitoring system.
That's the key.
Right.
And that's why it's so important to invest in research and development of GNSS-IR technology.
Okay.
We need to refine those algorithms,
Right.
improve the data processing,
Okay.
and make sure it works seamlessly with all those other flood forecasting systems.
Well, after this deep dive, I'm convinced that GNSS-IR is the future of flood monitoring.
It's very promising.
It has the potential to save lives and protect communities all over the world.
Absolutely. And the research backs it up. One study that highlights this potential is the one published in Geophysical Research Letters in 2024
Okay.
by Purnell et al.,
Okay.
titled Real-Time Water Levels Using GNSS-IR, a Potential Tool for Flood Monitoring.
That's the one we mentioned earlier, right?
That's the one.
The one about using low-cost antenna arrays.
Right.
What exactly did they do in this study?
They developed a new method for getting those real-time water level measurements
Okay.
using a network of those low-cost antennas.
Okay, so they were definitely going for a more accessible and affordable approach.
Exactly.
And did they test their method in the real world?
They did. They set up their system at 2 sites
Okay.
with varying tides
Okay.
and compared their measurements to a pressure gauge
Okay.
that was already there.
So they had a benchmark to make sure their measurements were accurate.
Exactly. And the results were impressive.
Oh, wow.
Their GNSS-IR system was able to track the water level changes accurately and in real time
Okay.
with an accuracy of just a few centimeters.
So they essentially created a real-time tide gauge using GNSS signals.
Exactly.
That's incredible.
It is very impressive.
But what about the challenge of determining the datum
Right.
or 0 point for those measurements?
Right, that's important.
We talked about that earlier.
Yeah, they addressed that too.
Okay.
They used survey measurements
Right.
to figure out the exact vertical distance between the antennas and a known benchmark.
Okay, so they were very thorough.
Yes. They also found a slight bias in their measurements because of the atmosphere,
Oh, right.
but they were able to correct for that using a tropospheric delay model.
Okay,
So they basically calibrated their system to ensure the measurements were accurate and reliable.
got it.
Yeah, and their findings show that it's definitely feasible to use low-cost GNSS antenna arrays for real-time flood monitoring.
This is so exciting.
It is.
It means this technology could be deployed in communities all over the world,
Yeah,
giving them a valuable early warning system for floods.
I agree. And the researchers concluded that GNSS-IR water level sensors could be a powerful tool for not just flood monitoring,
Okay.
but also for storm surge monitoring
Yeah.
and water resource management.
Especially in remote areas where traditional methods are impractical.
Exactly.
So it's a versatile technology with far-reaching implications.
It really is.
It seems like there's no limit to what GNSS-IR can do.
You're right. This study is just one example of the amazing research being done in this field.
Okay.
And as the technology continues to evolve, we're likely to see even more innovative applications emerge.
Okay, I'm officially hooked.
Haha, great.
What other applications are on the horizon for GNSS-IR?
Well,
You mentioned sea ice monitoring earlier, and I'm really curious to learn more about that.
sea ice monitoring is a fascinating application,
Okay.
and it really showcases the power of combining data from different sources.
Right. It's like having a team of detectives working together to crack a case,
Exactly.
each bringing their unique skills and expertise to the table. Okay, so who else is on this sea ice detective team?
Well, one of the key players is satellite altimetry.
Okay.
It uses radar pulses to measure the height of the ice surface from space,
Okay.
giving us a large-scale view of sea ice extent.
So it's like having a bird's eye view of the Arctic,
Precise.
showing us the big picture.
Yes. And then we have synthetic aperture radar,
Okay.
or SAR,
Okay.
which can give us even more detailed information.
Okay.
SAR uses microwave pulses to create images of the ice surface,
Okay.
revealing features like ice type, concentration,
Okay.
and even those cracks and openings in the ice called leads.
So we're basically using different wavelengths of light to create a multi-layered image of the sea ice.
Exactly.
It's like having X-ray vision for the Arctic.
And what's the role of GNSS-IR in all of this?
Yeah, where does it fit in?
GNSS-IR provides that extra layer of information about the height and roughness of the ice surface,
Oh, okay.
helping us to create a more complete and accurate understanding of the sea ice environment.
This is incredible. We're using signals from space to monitor the frozen wilderness of the Arctic.
It is pretty amazing.
But why is this so important?
Well, sea ice plays a vital role in regulating our planet's climate.
In what way?
It reflects sunlight back into space,
Okay.
helping to keep the Earth cool.
So less sea ice equals a warmer planet.
That's a great analogy.
It's like we're losing a part of our planet's natural air conditioning system.
Exactly.
And this warming can lead to all sorts of problems.
Right.
From more extreme weather events to changes in ocean currents, which can disrupt fisheries and ecosystems.
Yeah, it's a really complex system.
Well, this is where I start to feel a little overwhelmed.
I understand.
It's a lot to take in.
It is.
But it sounds like monitoring sea ice with GNSS-IR and other technologies is giving us valuable information to help address these challenges.
Absolutely. The more we understand about how sea ice is changing,
Right.
the better we can prepare for the future.
Okay, so we've got this amazing team of technologies working together to monitor sea ice. Right. GNSS-IR, satellite altimetry, and SAR.
It's a powerful combination for sure.
Yeah, it's like having a whole toolkit for understanding what's happening in the Arctic.
Yeah, and as we learn more about sea ice,
Right.
we can start to make better predictions about things,
Like what?
like shipping routes,
Okay, yeah.
or even how climate change will impact different regions.
This is where it gets really important, right? I mean,
Yeah.
we hear a lot about melting ice caps and rising sea levels.
Right.
But how does all of this actually affect people's lives?
Well, sea ice plays a huge role in the global climate system.
Okay.
It's like a giant mirror reflecting sunlight back into space.
Okay.
Without it,
Yeah.
the Earth would absorb more heat,
Right.
leading to even faster warming.
So less sea ice equals a warmer planet.
Exactly.
Okay,
Yeah. It's like we're losing a part of our planet's natural air conditioning system.
that's a great analogy.
And this warming can lead to all sorts of problems.
Like what?
For more extreme weather events.
Oh.
To changes in ocean currents,
Right.
which can disrupt fisheries and
Yeah.
ecosystems.
This is where I start to feel a little overwhelmed.
It's a lot to take in.
It's a lot to take in.
Yeah.
But it sounds like monitoring sea ice with GNSS-IR and these other technologies is giving us valuable information
Yeah.
to help address these challenges.
Absolutely. The more we understand about how sea ice is changing,
Right.
the better we can prepare for the future.
Okay, that makes sense.
Yeah.
Let's switch gears for a moment
Okay.
and talk about some of the nuts and bolts of GNSS-IR.
Sure.
We've mentioned multi-frequency and multi-constellation GNSS a few times now.
Right.
Can you remind us why this is such a big deal
Yeah.
for improving the accuracy of the measurements?
Okay, so think of it like this.
Okay.
You're trying to listen to a faint radio signal,
Okay.
but there's a lot of static.
Right.
Using multiple frequencies and constellations
Yeah.
is like having multiple antennas
Okay.
picking up the same signal. Each antenna might pick up a slightly different version,
Right.
but by combining them,
Yeah.
you can filter out the static
Okay.
and get a clearer, more accurate signal.
So it's like noise-canceling headphones for GNSS-IR.
Exactly.
But instead of blocking out the sound of crying babies on an airplane,
Right.
we're blocking out the errors caused by things like multipath.
Exactly. Multipath is a big problem in GNSS.
Right.
Because the signals can bounce off buildings,
Right.
trees, or even the ground before they reach the receiver.
Okay.
This creates multiple paths for the signal to travel,
Right.
which can confuse the receiver and lead to inaccurate measurements.
Okay, so multi-frequency and multi-constellation GNSS helps us to eliminate those confusing reflections
Right.
and get a more accurate measurement of the signal's true path.
That's the goal.
What else are people working on to improve this technology?
Researchers are also developing more sophisticated algorithms to process the data.
Okay.
It's like having a team of expert code breakers working behind the scenes, figuring out how to extract the most meaningful information from the raw data.
So it sounds like data processing is just as important as the technology itself.
It is, for sure.
We need to be able to make sense of all those signals and turn them into useful information.
Absolutely. And as computing power continues to increase,
Right.
we're able to develop even more powerful algorithms that can analyze the data faster and more accurately.
So it's a constantly evolving field.
It really is.
This has been such an incredible deep dive.
It has been fun.
I feel like I've gone from knowing next to nothing about GNSS-IR to having a pretty good grasp of the basics.
Yeah, we covered a lot.
But more importantly, I've gained a whole new appreciation for the power of this technology and the impact it's having on our understanding of the planet.
It's an exciting field, for sure.
Yeah, and all the different things we can do with it.
Absolutely.
Okay, before we wrap things up,
Sure.
let's give our listener a few key takeaways
Okay, sounds good.
to ponder as they go back out into the world.
What are your top three?
Well, first and foremost, GNSS-IR is a revolutionary technology
For sure.
that's changing the way we monitor and manage our planet's water resources.
Definitely.
It's accurate, cost-effective, and incredibly versatile. And it's being used for everything from tracking sea level rise to predicting floods to monitoring sea ice.
And more applications are being discovered all the time.
Yeah, exactly. So GNSS-IR is a prime example of how scientific innovation is happening across many different fields.
It really is.
From improving satellite systems
Yeah.
to developing sophisticated data processing algorithms. It's a true testament to human ingenuity.
It really is amazing.
And finally, I think it's important to remember that GNSS-IR is not just about technology.
Right.
It's about people.
It is, yeah.
It's about scientists and engineers working together to develop solutions to pressing global challenges.
That's right.
It's about communities coming together to protect their local water resources.
Mm-hmm.
And it's about all of us recognizing the interconnectedness of our planet's systems. Yes.
And working together to ensure a sustainable future.
Beautifully said. I think that's a perfect note to end on.
It's been a pleasure diving deep into the world of GNSS-IR with you.
The pleasure was all mine. And to our listener,
Yeah.
don't forget to check out the show notes for links to all the research we discussed.
Yeah, we've got a lot of great resources there.
And keep exploring.
Happy diving!